Okay, here we go. Looks like we're live now. Getting ready to start day one. So I haven't even seen the first problem yet. So how hard can it be? Okay, day one, sonar sweep. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine the elves keep ready for situations like this. It's covered in Christmas lights, because of course it is. And it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 through 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, suppose you had the following report: 199, 200, 208, 210, etc. This report indicates that scanning outward from the submarine, the sonar sweep found depths of 199, 200, 208, 210, and so on. The first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. There is no measurement before the first measurement. In the example above, the changes are as follows. No increase, decrease, etc. In this example, there are 7 measurements that are larger than the previous measurement. How many measurements are larger than the previous measurement in the puzzle input? Okay, so we're set up. We lost the keys, and so we need to find all 50 stars to find the keys to the sleigh to save Christmas. Okay, so there's the puzzle input. Let's see. This looks okay. Copy that and do day one input. I'm just make it name it input and paste this in. And let's create solution.rb. Okay, so the test that we have here is these numbers. And just like in the input, we've got new lines. So let's see, there's probably an easy way to do this, but usually the problems, well, there's definitely an easy way to do this, but usually the problems have a second part, or the problems are all going to have a second part that builds on the first. And so you're kind of rewarded for designing it a little, like working on an API or designing out some objects here. But the first thing that comes to mind is, is to just do it in a naive way and keep a tally. Just count the number of times a depth measurement increases from the previous measurement. So what we need to do is we've got a problem input equals this. That should keep the new lines. We've got a previous. Actually, what we can do is let's put that on new line, and so now we've got a these early ones don't necessarily have to be very efficient, so I can do some pretty inefficient things to make it easy to work with for now. So we've got an array of integers now. So previous is going to be the input, the first element in input, and then if we do, well, let's do this actually. Instead of that, and make it easy to swap out the input file. Make it test input equals that. And input equals test input dot split. Okay, and then we've got previous equals input 0. Increased count equals 0, and then we do input dot each, or well, input sub. Let's see. Let's test out. I forget. I haven't done Ruby in a long time, so I forget what the actual syntax of this is. A -1 or 1 to -1. No, A 1 -1 2 3 4. Cool. Put 1 to -1. So it's the skip the first element and go to the last element. Each do depth measurement and increased count equals increased count plus 1 if depth measurement let's change this to previous depth measurement greater than previous depth measurement, and then previous depth measurement equals depth measurement, and then we just put increase count, and we probably should have done this first, but I like to do a put an output here of it expects it to be 7, and got increased count. Okay, so that should work. Let's see what we get here. Run solution to RB. Expect 7, got 7. Cool. So now we can. So the test works. Then let's do the same thing, but we've got. Input equals file dot read input backwards input dot or actually I don't really remember the difference here, but I think I usually do it like this: split n app to my. So I could have changed that, but. Anyway, so that's all going to be good, and then got count, and let's see where we're at. is 1692. Hey, right answer. Okay, so now on to the second part. And so usually this is going to be, since I didn't model this out at all, I'm going to be probably needing to rewrite a lot of this, but let's see what we've got. Considering every single measurement isn't as useful as you expected, there's just too much noise in the data. Instead, consider sums of a 3-measurement sliding window. Again, considering the above example, I'm not going to read that out. Start by comparing the first and second 3-measurement windows. The measurements in the first window are marked A. Their sum is 199, 200, 208. The second window is B. Its sum is... The sum of measurements in the second window is larger than the sum of the first, so this first comparison increased. Your goal is now to count the number of times the sum of measurements in this sliding window increases from the previous sum. So compare A with B, B with C, C with D, and so on. Stop when there aren't enough measurements left to create a new 3-measurement sum. In the above example, the sum of each 3-measurement window is as follows. Okay, so we kind of create the same thing. So we need to pre-process that and then run the same algorithm on the new numbers. Example, there are 5 sums larger than the previous sum. Consider sums of a 3-measurement sliding window. How many sums are larger than the previous sum? Okay, so first pass is we need to take these first numbers, turn them into these second numbers, and then run the same process. Okay. So, let's give ourselves a clean file here. So first step is I want test input to be the same. And I want whatever, let's say, so I want, let's say I have a method called process input that takes an input, or let's say, what's a good name for this? Windowify. Let's do start by 3-measurement window. The measurements of first measurement window. Measurement window sums of value, and we do test values correct, and let's make sure that that's equal to expected test output of it's probably helpful to just have an array, so I don't need to have it be split because I interact with it as an array in the first part. So this can just be 607, 618, 618, 617, 647, 716, 769, 792. And we expect this to be equal to expected test output. Okay. So now we just need to define this measurement window sums method. And that takes yeah, well, this takes and did that there. Do I really? Well, whatever, doesn't matter. I can send in the file data without the split in the map. So, okay, so measurements, and we do process measurements equals measurements dot split map. Turn them all into integers. Okay. And so what we expect here, so what we want to do is have the first one, first, second, third. I actually think there's a method for this. Anyway, so let's do, first thing that comes to mind here is we can just do an empty array. So output equals this, turn output, and so we want to do processed measurements dot each with index. Okay, so we've got measurement and the index. And what we want to do is, let's say, so if there's not enough for the sliding window, we need to stop. So what we need to do is make sure that we stop. So let's do break if processed measurements sub index plus 1. Actually, if not, if there's no index plus 1, and if there isn't a processed measurements index plus 2. Pretty sure that'll work in this, but I guess we'll find out. And so if it is, then we just output add to the output of measurement plus processed measurements sub index plus 1 plus processed measurements index plus 2. And that should give us the right values. I think. Just add the sums, add them the output. I'm not mapping them to letters because it doesn't seem like that matters when we're on part 2. So there's nothing more to be done here. Oh, unterminated string meets end of file input. Helps to close strings. Nil can't be coerced into integer plus. Okay, so that's on line 20. Yeah. It's not an and, it's an or. If either of these are not right. Okay, so we got that right. So that was more if either of those, it's not if both of those don't exist, it's if either of them exist, because we don't want to add 260 and 263 as well. Okay, so now it's just a matter of getting the file input again. So let's do that here. I can leave that. And we do problem input equals file.open input.read .read, and then we can just take this. I could probably move that into a method to make it easier. You probably could have used one file, but I didn't. So now we've got that. We now need input equals measurement window sums of problem input. Previous depth measurement is 607, and and then that should work. I guess one of the things we could test is if depth increase counts expected 5 got. It'd be nice, I guess maybe for next time I'll have RSpec set up because it'll be easier to write test expectations than doing them by hand, but increased count, and let's copy this here. Let's see what happens here. Expected 5, got 5. Okay, so now we just output increased count. And problem solution is 1724. Let's see if that's right. Hey, the right answer. Okay. All done with day 1. I can learn a couple, one thing to kind of do for tomorrow is to maybe try to get RSpec set up. But that's all I've got. Probably shoot for some same time tomorrow if there's anybody out there watching. But see you tomorrow.